So let's say I have two switches, switch 1 and switch 2. I have two link between switch 1 and switch 2. And on switch 1, let's say we have some users here. Some users are in VLAN 10, some users are in VLAN 20, or some user in different VLANs. Fine. This is my, let's say, topology. Fine. This link is trunk link. Trunk link. This link is also trunk link. Trunk link. This is my switch 1. This is switch 2. This is PC1. This is PC2. PC3 and PC4. Right. Let's say this PC1 is in VLAN 10. PC2 is in VLAN 20. PC3 is again in VLAN 10. And PC4 is in VLAN 20. So by default, STP is running on both switches, right? Here also STP is running, here also STP is running. So STP will allow how many link between switch 1 and switch 2? 1. Right? Let's say MAC address of this switch is 0A, MAC address of this switch is 0B. Right? So let's say this port is DP, this port is also DP, this port is RP, and this port is, let's say, alternate, right? So this port will be in blocking state, right? So my upper link is overutilized, right? My all traffic of VLAN 10 as well as traffic of VLAN 20 will be carried from upper link, right? Let's say PC1 want to communicate with PC3. PC1 will forward data to switch 1, switch 1 will forward data from this link, right? For VLAN 10 also, for VLAN 20 also, right? So I am not using this link, lower link, right? Lower link will be in blocking state until and unless upper link will not goes down, right? Switches is not going to use lower link, this link, correct? So my lower link is underutilization, upper link is overutilization. So in case of CST, in common spanning tree protocol, right, we cannot use both link. We cannot use both link. So that's why Cisco come with PVST protocol. PVST stands for per VLAN spanning tree protocol. Per VLAN spanning tree means for one VLAN, STP will run one separate instances, right? So if we have 100 number of VLAN on switches, STP is going to run 100 number of instances. But again, if we have, let's say, only one VLAN on switch 1 and switch 2, if we have only one VLAN, right, then guys, there is no any difference between CST and PVST. There is no any difference between CST and PVST. But when we have multiple VLANs, right, then there is huge difference between CST and PVST. Then CST will run single instances, but PVST will run multiple instances. So with the help of PVST protocol, what I can do, I can utilize both link. I can utilize both link. I can make this switch as a root bridge for VLAN 10, and for VLAN 20, this switch is my root bridge. So for VLAN 10, I am, let me use this color. This port is going to be what? DP. Let's say these two ports are DP for VLAN 10, and for VLAN 20, switch 2 is my root bridge. So this port will be DP, this port will be DP, this port will be RP, and this port is block. So for VLAN 20, we are using lower link. For VLAN 10, we are using upper link. Right? But if any link will goes down, if let's say this link will goes down, right? So now for VLAN 10 also, we will use lower link, and for VLAN 20 also we will use lower link. Getting my point? So with the help of PVST, we can achieve load balancing for VLANs, right? And as I told you in last class, PVST was not compatible with CST. That's why Cisco replaced PVST with PVST plus protocol. PVST plus. Okay, clear? So if we have only one VLAN on switches, then PVST or CST, both protocols work same. Both protocol will work same. Both are going to maintain single instances. One switch will become root bridge and another switch will become non-root bridge. Fine. Okay. Then we have what problem? We have problem in PVST as well. We have problem in PVST plus as well and in CST as well, right? Problem of uplink fast, right? Port fast. Then
Backbone
not
fast.
not backbone. Yes, backbone fast. Backbone fast. Right. So actually, what problem we have? We have slow convergence, right? In these all three protocol, convergence is very slow. Convergence is very slow. Whenever we connect computers, they need 30 seconds to come in forwarding state, or whenever we will connect link between switches, they will take 30 seconds to come in forwarding state, or whenever change will occur in the topology, right, all ports will take 30 seconds to come in forwarding state. So in CST, PVST and PVST plus, we have slow convergence. So that's why we come up with which protocol? RSTP. RSTP is an open standard protocol. Let me tell you some basic points about RSTP protocol, then I will continue. Rapid spanning tree protocol. Fine. First point is it is an open standard. Open standard means we can run it on Cisco devices as well and on non-Cisco devices as well. After that, main advantage of RSTP protocol over CST, PVST or PVST plus is convergence. Convergence is very fast, very fast. You will see how. Okay. Then we still need port fast service here for LAN interfaces for edge port fast is still required. Fine. And RSTP is going to maintain again single instances for all VLAN. Single instance for all VLAN. So that's why Cisco come up with RPVST, right? So again in RPVST, switches is going to run multiple instances for multiple VLAN. Fine. Now what you need to understand in RSTP, because see, concept of root bridge election, concept of root port election, concept of designated port election, alternate port election, those things are exactly same in RSTP like CST, exactly same. Just we need to understand how this protocol is fast, how convergence is fast in RSTP protocol. Okay. So first of all, I would like to ask you this question, guys. How many states we have in CST? How many states we have in STP? Disable?
5 states.
Okay. Tell me the name of each. Disable?
Disable, block,
Blocking. Then
listening, learning,
listening, learning,
Forwarding.
forwarding.
forwarding. When port will come up, right, a state will move from blocking to listening quickly, but in listening state, port will spend how much time?
15.
15 seconds. In learning state also, port will spend how much time? 15 seconds. So a port will take 30 seconds to come in forwarding state, right? This is a state of CST. If I will talk about a state of RSTP, so see RSTP states. In RSTP, we have 3 states only: discarding, then we have learning. We don't have listening state over here. learning, and then forwarding. Right? Switch will spend 15 seconds in discarding state, 15 seconds in discarding state, and 15 seconds in learning state. Again in RSTP, a port will take how much time to come in forwarding state? 13 seconds, right? This discarding state is combination of disable, blocking, and listening. We have combined these three states into single state in RSTP, that is called discarding. And learning is same, forwarding is same. Fine. So in RSTP also switches will take a switch port will take 30 seconds to come in forwarding state, right? So these are states of RSTP protocol. These are states of RSTP protocol. Now let me compare port role with STP. So in STP, how many port role we have? Port roles in STP. Yes, we have alternate port, then RP, then DP, right? So alternate port is nothing but backup of RP. Now if I will talk about port role in RSTP, port roles in RSTP. So in RSTP we have 4 ports role. We have 4 types of port roles. First one is again alternate, then we have backup, alternate, then we have backup port, backup, then we have DP, or you can say RP, and DP. See, in CST, in common spanning tree protocol, or in PVST, alternate port is backup of RP. Is there any backup port of DP? No. But in case of RSTP, alternate port is backup of RP and backup port is backup of DP. So whenever a DP port will goes down, right, backup port will become what? DP. Whenever a RP port will goes down, alternate port will become what? RP. Fine. If I will talk about BPDU. So how many types of BPDU we have in CST? 2. First one is configuration BPDU, that root bridge will send after every 2 seconds. Configuration BPDU. First time all switches will send configuration BPDU because first time all switches will think I am root bridge, right? But once a root bridge election will happen, right, one switch will become root bridge, then only root bridge is going to send configuration BPDU after every 2 seconds. And whenever change will occur in the topology, then we have TCN BPDU. But if I will talk about RSTP, so we don't have TCN BPDU here. We have only one BPDU, that is configuration BPDU. We have only one BPDU in RSTP protocol. And all switches will generate configuration BPDU. Fine. Clear till here? Now see, I want to show you something here. In this topology, spanning tree protocol is by default running. Let me capture any link. I am going to capture, let's say 0/0, because 0/0 is my DP. So switch 1 is sending configuration BPDU from this interface, right? If you will open this configuration BPDU, any BPDU, if you will open this configuration BPDU, you can see the flag field. Flag field is here. As I told you, BPDU will carry multiple information like version, protocol identifier, BPDU type means which type of BPDU it is. Then we have root breeze ID, we have breeze ID, right? We have messages, max age timer, hello timer, right? And forward delay timer. So I am interested to make you understand flag here, right? If you will understand the flag field, that means you have understood the RSTP protocol. Everything is here, guys, in flag. So we have 8 bits for flag. We have 8 flag total, right? But CST or PBST plus, these protocols use only 2 flag. These protocols uses only 2 flag bit, and rest 6 are not in use for CST, PBST and PBST plus. Topology change acknowledgement and topology change. Topology change is first flag and topology change acknowledgement is last flag, right? In RSTP, topology change acknowledgement is not in use, but rest flags, we have 6 more flag, right, in PPDU. So we are going to use those 6 flags in RSTP protocol that was not in use in CST, PBST and PBST plus. If you will open any BPDU, you will see there will be only these 2 flag, and by default you can see both flag is off. Getting my point? So let me tell you about all 8 flags here. See, we have 8 flags of BPDU. 0, 1, 2, 3, 4, 5, 6, 7. We have these 8 flag, right? 0 is TC flag, TC, and 7th flag is, means 8th flag is TC ACK. This is TC ACK flag acknowledgement, right? Only we are using these 2 flag in case of CST, in case of common spanning tree protocol, as I show you here also in capturing, right? But in RSTP we are going to use these all flags, right? So let me tell you what is flag number 1, flag number 2, flag number 3, 4, 5, 6. Okay, flag 1 is proposal bit. This is proposal. What we call to this flag? Proposal, right? Flag number 2, this flag is called, flag 2 second bits and third bits. Second bits and third bits is going to represent port role, is going to represent port role. This is for port role, port role. This flag is also for port role, port role. If I will talk about this flag, fourth flag, so fourth flag is going to indicate learning state, is going to indicate learning state. So whenever a state is learning, right, then switch will send BPDU with this flag on, right? If a state is going to be what, forwarding, then switch will on this flag bit, right? So flag number 5 is going to represent forwarding state, and sixth flag is agreement flag. This flag is agreement flag. Fine. So first of all, understand flag number 2 and flag number 3. Flag number 2 and flag number 3. So what I am saying is, if flag number 2 and flag number 3 is 0, 0. If flag number 2 and 3 is 0, 0, that means this is reserved. This is again not in use, unused. If flag number is 0 and 1, that means it is an alternate port. It is an alternate port. If flag bit is 1, 0, that means it is an root port. If flag is 1 and 1, that means it is an designated port. Clear? If flag 2 and flag 3 is 0, 0, in RSTP I will capture again link, right, in RSTP, and you will see these flags are going to be used there. And if flag 2 and flag 3 is 0 0, right? That is not in use, as I told you. If flag number 2 is 0 and flag number 3 is 1, that means it is an alternate port. If flag number 2 is 1 and flag number 3 is 0, that means it is an root port. If flag number 2 is 1, flag number 3 is also 1, that means it is an designated port.
Then what about backup port?
Backup port? No,
There are
for backup port, again, which port will become alternate port? Port which will not become DP or RP. That port will become what? Alternate. Same thing will happen in RSTP. Port which will not become alternate, RP and DP. That port will become what? Backup.
No, I'm asking the code, this bits, these flags.
We don't have any flag for backup.
Okay.
Fine. Now question is how RSTP is fast. How convergence is fast in RSTP protocol. So try to understand with one example. Let's say I have two switch. Switch 1, switch 2. Let's say this is 0/1 and this is also 0/1. Let's say link, this port is shut down. So when port is shut down, both switch will think what I am? Root bridge. I am root bridge. MAC address of this switch is 0A, MAC address of this switch is again 0B. So both switch will send superior BPDU. Both switch will send BPDU from their link, right? It is also sending BPDU, it is also sending BPDU. And in that BPDU, both switch will on proposal bit, right? So what we are saying to this BPDU, we are saying switches is sending proposal. Switches are saying proposal, but proposal is nothing but BPDU with proposal bit on. Okay. Okay. If this switch is sending BPDU, so this port will become what? DP, and this port is also what? DP. Because let's say link is not working, right? Link is down here. So both switches sending BPDU from their interface, and port roll of both switches is DP. So it will on which bits? Flag number 200, as I told you, this is unused. 01 is for alternate, and 10 is for root port, and 11 is for designated port. We can say DP, right? So this port is what? DP. So it will on flag number 2. Yes, flag number 2 will be 1. Flag number 3 will be also 1. And which bit will be on? This port is what? DP. Flag number 3. Sorry, 1 will be also on. No? So it will set proposal. So flag number 1 will be on. Flag number 2 will be on. Flag number 3 will be on. These 3 flag will be on in this BPDU. First bit showing proposal. Second bit showing what? Second and third bit showing what? It is DP, designated port. It is DP. So first time both switch port is DP, and both switch are root bridge. So both switch will send BPDU with proposal bit on BPDU, and port roll is DP, so it will on bit number 2 and 3 also. But let's say when link will come up, which switch will receive superior BPDU? When link will come up, which switch will send superior? Which switch will receive superior BPDU?
Switch 2.
Switch 1 and switch 2. Switch 2 will receive superior BPDU, right? On 0/1 port. So 0/1 port will become what? RP or DP? This port will become what? When this link will come up. switch number 2 will receive superior BPDU over here, right? It will receive superior BPDU on 0/1. So whenever switch receives superior BPDU on port, that port become what? RP, yes or no? So this port will become
Yes.
what? Quickly RP. Now this port will take how much time to come in forwarding state? 30 seconds in discarding state, 30 seconds in learning state, right? Then it will come in forwarding state. But in RSTP, see, on switch number 2 will receive superior BPDU over here. First of all, always keep in mind, whenever a switch receives superior BPDU, that switch is going to perform two tasks. On switch 2 will receive superior BPDU, this switch is going to perform two tasks. This is game of RSTP, guys. This is game of RSTP. This two task is going to make RSTP protocol faster than CST or PVST. First task is it will perform synchronization. First of all, it will perform synchronization. Synchronization means the receiving port will become RP. First of all, receiving interface will become RP, and then it will perform synchronization. First task is synchronization. Synchronization means put all the interfaces in discarding state except receiving interface. Put all the interfaces in discarding state except receiving interface. So let's say here we have on switch number 2 we have some user and we have some more links, like link connected with switch number 3. So switch 2 is going to put all their interfaces in discarding state except 0/1 interface, because it is receiving superior BPDU on 0/1. This is meaning of synchronization. In book also, if you will read book what is synchronization, you will see synchronization means putting all their interfaces in discarding state except receiving interface. So on switch will receive superior BPDU, it will perform two tasks. You can say three tasks. One task is that port will become RP. Second task is it will perform synchronization. Synchronization means except receiving port, it will put all their interface in discarding state. And third task is it is going to send one agreement from that interface. It is going to send agreement bit on BPDU. Agreement bit on BPDU. So switch 2 will receive superior BPDU on 0/1 interface. First of all, this interface will become RP. After that, switch 2 will put their all interface in discarding state, and then switch 2 is going to send what? Agreement. Agreement means agreement bit on BPDU. Agreement flag on BPDU. It is going to send agreement from here. Fine. It will on agreement bit in their configuration BPDU, and then it will send to switch number 1, or you can say from that interface where it have received superior BPDU. And whenever agreement bit on BPDU transmit from a port, or whenever a port receive agreement bit on BPDU, that port will come in forwarding state quickly. This is rule of RSTP protocol. Whenever a port transmit or receive agreement bit on BPDU, that port will come in forwarding state quickly. What I am saying? Whenever a port transmit or receive agreement bit on BPDU, that port will come in forwarding state quickly. So now you tell me, when switch 2 will receive superior BPDU on their 0/1 interface, this interface will become RP. After that, switch 2 is going to put their all interface in discarding state, and it will send one agreement from the receiving interface. So once this interface will transmit agreement bit on BPDU, this port will come in forwarding state quickly, and once switch number 1 will receive agreement bit on BPDU, this port will also come in forwarding state quickly. Yes or no? So now guys, tell me how much time these switches have taken to convert the topology. It have converged the topology in millisecond. RSTP protocol is going to converge the topology in millisecond. Why? Because of these two flag, proposal and agreement. Because of agreement flag, right? RSTP protocol is very fast in convergence. In convergence. Okay. So this is the point that you need to keep in mind, that whenever switch transmit or receive agreement bit on BPDO, that port will come in forwarding state quickly. Now question is, let's say here I have same topology, switch 1, switch 2. Here let's say we have one link, we will connect more link as well. Let's say here we have some user. Fine, this is switch 1. Again, switch 1 MAC address is, let's say, 0A. Switch 1 have lower MAC address than switch 2. This is PC 1, PC 2, PC 3, 4, 5, and 6. Now, this port is, let's say, again 0/1, and this port is also 0/1. First of all, when I will enable RSTP protocol here, RSTP, here also I am running RSTP, here also I am running RSTP. First of all, both switch will send what? Proposal bit on BPDO. Proposal bit on BPDO. This switch will also send proposal, and this switch will also send proposal, right? Both port is DP, DP. But on switch 2 will receive superior BPDO. Over here, first of all, this port will become RP. It will put these all interfaces in discarding state, and it will send what? One agreement. Once it will set agreement, this port will come in forwarding state, right? And on switch number 1 will receive agreement flag on BPDU, this port will also come in forwarding state. But again, this port will take how much time to come in forwarding state? 30 seconds, discarding state, after that learning state, and then forwarding state. So that's why I told you, in RSTP also we need to enable what? Port fast. So here we will enable what? Port fast, right? So this port will come in forwarding state quickly because of port fast feature, and between switches link will come in forwarding state quickly because of agreement flag, Clear? Clear, guys? This is the RSTP protocol. Now we can, see these things in practical also, or I can, make one another topology here. Let's say I have switch 1 and switch 2. Switch 2, switch 1. We have two link here, 0/1, 0/2, 0/1, 0/2. Same thing will happen in this scenario also, right? First of all, both switch will send BPDU from their both interface, because both switch will think I am root bridge, right? So these ports are DP by default. At the initial time, this port will be DP, this port will be DP, this port will be also DP, this port will be also DP. But on switch 2 will receive superior BPDU. It will first of all tell me switch 2 will receive superior BPDU on which interface? Switch 2 will receive superior BPDU on which interface? It is receiving BPDU on both interface. It will receive superior BPDU on 0/0. Yes or no, guys? Because first it will check root bridge ID, then cost. Same cost is same, root bridge ID is same. Then it will check what? Sender bridge ID, that will be also same. Then it will check what? Sender port ID, designated port ID. So port ID of this interface is lower than this interface. So this port will become what? RP. And from this port, once this port will become RP, switch will put this interface in discarding state, and it will set one agreement from here. So this port will come in forwarding state, this port will also come in forwarding state quickly, right? Now when this port will come in forwarding state? This port will never come in forwarding state, because port role of this port is going to be what? Alternate. So doesn't matter, this port will take how much time, or let's say switch 2 is connected with one another switch number 3, right? So switch 2 will relay the superior BPDU from this interface. So this port will become what? DP. On switch 3 will receive superior BPDU on this interface. Again, switch 3 is going to perform 3 tasks. First, this port will become RP and it will send what? It will perform synchronization, then it will set agreement. On switch 2 will receive agreement. This port will come in forwarding state. This port will also come in forwarding state quickly, right? In CST, we discuss many type of topology change, right? See what will happen when topology change will occur in case of RSTP. Again, let's say we have 3 switch 1, switch 2, and switch 3. We are running RSTP protocol. So this port is DP, this port is DP, this port is RP, this port is RP, this port is DP, and this port is alternate, right? When this link will goes down, what will happen? Earlier it was receiving superior BPDU on this interface. In CST, PVST and PVST plus, there is max age time, that whenever this link will goes down, then also switch 2 is going to keep that information for 20 seconds. But in RSTP, once this link will goes down, switch 3 is going to flush the BPDU which switch was receiving on this interface, right? On this link will goes down, switch is going to flush BPDU immediately. And now switch 3 is receiving BPDU on this interface. So now it is receiving superior BPDU on this interface. So what this switch will do? It will perform what? Synchronization, and it will set one agreement, right? So once it will set agreement, this port will come in forwarding state. First of all, it is receiving superior BPDU over here. So this port will become RP, and once it will send agreement, this port will come in forwarding state. On switch 2 will receive agreement bit on BPDU, this port will come in forwarding state quickly, right? So within nanosecond, RSTP is going to converge the topology if change will occur. Getting my point? Same thing, this is what? Direct topology change. Same thing will happen in indirect topology change also. Let's say here, if this link will goes down, link between switch 1 and switch 2, this link will goes down, what will happen? Earlier switch 2 was receiving superior BPDU on this interface. Now it is not receiving any BPDU over here, right? So in RSTP, it will flush that BPDU immediately, and it will send what? Their own BPDU as superior BPDU. Switch 2 will start declaring their self as root bridge, because now switch 2 is not receiving any BPDU on their any interface. And when switch 3 will receive BPDU of switch number 2 in RSTP, quickly switch 3 is going to relay superior BPDU to switch number 2. Quickly it is going to send BPDU of switch 1 to switch number 2. So this port will come in forwarding state quickly, and this port will also come in forwarding state quickly, because once this port will become RP, sorry, this port will not become RP, this port will become DP, right? Because earlier it was receiving BPDU over here, now it is sending BPDU from here, right? So when change will occur in the topology, RSTP can converge topology quickly within nanosecond. So that is the reason why we are using RSTP protocol nowadays in real time. We are not using CST, we are not using PVST, right? By default on Cisco switches, you will see the STP protocol which is running is PVST. But in real environment, in production environment, you will change PVST to RSTP, you know, PVST to RPVST, this protocol. Right here, you know, don't need to configure uplink fast or, you know, backbone fast. Those features, those are already inbuilt. So in this scenario, what I am going to do, on these switches I am going to configure RSTP protocol. First of all, you can verify which protocol is running on this switch, and this is Cisco switch, so here we will run RPVST. On non-Cisco switch, you will run RSTP, right? On Cisco switches, you cannot run RSTP protocol. You will run RPVST, Rapid Per VLAN Spanning Tree. So, a spanning tree summary. Which protocol is running? This is PVST plus. This is PVST plus. and you can see these all features are disabled. Fine. Now, so spanning tree, these all ports of switch 1 is designated port because switch 1 is my root bridge in this scenario. So if any port will goes down, interface E0/1 shut down and no shutdown, and so a spanning tree, this port is in listening state, right? After 15 seconds this port will come in forwarding, learning state, then it will come in forwarding state, right? So it's taking 30 seconds. It will take 30 seconds to convert the topology learning state. Now it will come in forwarding state, right? Still we have capturing. Yes. So what I am going to do here, I am going to change a spanning tree protocol. I am going to run a spanning tree mode, and you can see how many options you have. You can run PVST or rapid PVST. So here I am going to run rapid PVST. Okay, on switch number 2 also I am going to run rapid PVST. Enable config T spanning tree mode rapid PVST. Right, how to verify? So spanning tree summary, which protocol is running? Rapid PVST. Actually this is rapid PVST plus. Fine. And so spanning tree, these are LAN interfaces. So these ports are in learning state, but link between switches are, you can see, in forwarding state, right? We have two link here. I'm going to down one link. Let's say 0/1. I'm going to down 0/1 interface here. Interface E0/1 says shut down. On switch number 2 also I'm going to down E0/2. Sorry, 1. Interface E0/1 says shut down. Right. So spanning tree. So spanning tree. Fine. These all ports are DP. Now we have only one link between switch 1 and switch 2. That is 0/0. E0/0. I'm going to down E0/0 interface also. Interface E0/0. Say what? Shut down. Shut down. So spanning tree. Fine. So now on switch number 2, debug spanning tree events. And so spanning tree. This switch is what? Root bridge. Why this switch is root bridge? Because we don't have connectivity between switch 1 and switch 2. We don't have connectivity between switch 1 and switch 2. That's why switch 2 is saying what? I am root bridge. And their all interfaces are DP in forwarding state. Right? If I will capture this link here, the 0/0. Switch 2 is sending BPDU. Let me open this BPDU. Where is flag field? BPDU flags. How many flags are there? 8. And how many flags are? See. Getting my point, guys? Why flag number 2 and 3 is on? Because this port is what? DP. This port is DP. And status was learning, so that's why here this bit is also on, right? Now in latest BPDU, let me check this BPDU. So it's I'm on learning BPDU also, bit also, and the state is forwarding, so that's why it have on this bit. Okay, leave. Proposal bit is agreement bit is 0. But when link will come up, see here I am going to use debug. First of all, let me close this caption. We have one caption here. On switch number 2, debug spanning tree events and config t interface e0/0, say no set here. On all. Fine. See the log messages here. RSTP initialization from port E0/0. This port is first, this port become DP, then transmitting proposal to E0/0. Receive agreement on 0/0, right? And once it will receive agreement, ports will come in forwarding state. Ports will come in forwarding state. Now what we can do here, we can verify interface E0/0, say shutdown, and do so spanning tree, right? Do so spanning tree. I'm going to run no shut command now on this interface, say no shut, and do so spanning tree. You can see this port is in which state? Forwarding state. Shutdown and no shutdown. Do so spanning tree. Forwarding state. So ports are coming in forwarding state quickly because of agreement. In the capturing, actually I have to find, right, which one is the first BPDU. This port is RP. One zero port is RP. Agreement proposal off. So actually when a non-root bridge switch will receive superior BPDU, right, it will turn off proposal bit. It will turn off proposal bit. And now only root bridge is going to send BPDU. But again here on router number 1, sorry, on switch number 1, let me say no shut to this port and so spanning tree, right? All ports are in forwarding state. Let me take you to switch number 2. On this switch, on all, config t interface E0/0, say shutdown, and do so spanning tree. Okay, now I am going to run no shut command here. What will happen? It will put these two interfaces in discarding state, yes or no? It will put these two interfaces in discarding state because of synchronization. So say no shut and then do so spanning tree. You can see it have put these two interfaces in discarding state. It's showing you block here, but this is discarding state. This is discarding, right? This port will again take 30 seconds, but you can see this port 0/0 has come in forwarding state quickly. Getting my point? This port is in learning state, right? So again we have to enable port fast on edge port. So what command I can run here? A spanning tree, port fast, default, port fast, edge, and then we can say default. This command will enable port fast feature on all access port except trunk link, right? So before running this command, we should configure E0/0 as trunk. Interface E0/0. We can say switch port, trunk encapsulation dot 1q, and then switch port mode, let's say dynamic desirable. Fine. And now I am going to run this command: a spanning tree, port fast, edge default. Fine. And now if E0/0 will goes down, shutdown and no shutdown, and do so a spanning tree, you can see all ports will come in forwarding state quickly. Actually this port is still my access port, right? So on this port also port fast service is enabled. Do so interface trunk. So now this link is trunk, but earlier maybe this port was access port 0/0. Now you can see, right? Again, if this port will goes down, shutdown and no shutdown, and do so spanning tree, you can see all ports will come in forwarding state quickly. All ports are in forwarding state. Getting my point? It's saying 0/0 is also is. Yes. Fine. 0/0 is my RP. Now if I will up E0/1 interface also, interface E0/1 say no set. On switch number 1 also, interface E0/1 say no set. And so a spanning tree. All ports are DP and STT is forwarding, so a spanning tree. All ports are DP except 0/1. This port is in which state? In blocking state. This port will take 30 seconds. No, this port will be, this port role is alternate, so this port will be in blocking state. Sorry, this is 0/1. I was thinking about this interface. On switch number 1 also we need to enable port fast feature. On switch number 1 also I can enable port fast feature. A spanning tree, port fast, edge default. And before running this command, let me check trunk. Do so interface trunk. So yes, this link is trunk, so we can run so a spanning tree, port fast, edge default. Right now interface E0/0, shutdown and no shutdown, and do so a spanning tree. You can see all ports are in forwarding state, right? So now user don't need to wait for 30 seconds or for any interval of time. If any change will occur, RSTP is going to convert the topology quickly.
But here again that port first is enabled on that 0/0 also.
Now this is problem of this simulation software.
No,
So
actually we have to go to that particular interface now, then we can
here
move
you
to
can see now E0/0 is not a port.
Oh.
E0/0 is, it's taking some time, right? Here.
Okay.
This interface is not trunk interface, that's why it's saying right edge. Actually we are running, whenever we are running a spanning tree port fast command, you should make sure that link between switches is configured as trunk, right? Otherwise it will enable port fast feature on trunk, on the link which is connected with another switch as well. Now any question?
What does that edge mean?
Edge means edge point, end point. This interface is connected with user, na? 0/2 and 0/3. So these are edge point.
Why it's showing 0/1 as edge?
Because this interface is member of VLAN 1 access port. So either you can enable port fast on the interface or you can enable it globally in global config mode. So if you are enabling port fast in the global config mode, it will on port fast service on all access port. So you should configure E0/1 as trunk. So interface E0/1, link between switches must be configured as trunk, right? So switch port trunk encapsulation say .1q, and then we can say switch port mode dynamic desirable. And now you can check do so spanning tree. Fine. Now these two interfaces are edge point. Edge means connected with end devices where port fast is enabled. Once you will enable port fast on any interface, you will see edge over here.
Okay. What is that forward delay in the output?
Where?
On the top. Aging time. This one. Forward delay 15 seconds.
This one?
Next to max age. That one.
This. Okay.
What is the difference between this 20 seconds and 300 seconds max age?
20 second and 303. Where is 300 second?
Initially, you told no aging time here. The bridge.
That is MAC aging time. 300 second is MAC aging time. That whenever switch will learn a MAC address dynamically, it will keep that information for 300 second in their MAC address table. And max age time is what? Max age time is like hold on time. Means when switch 1 will send BPDU. When switch 1 will send BPDU to switch number 2. Max age is 15 seconds. That means switch 2 will keep that information for 15 seconds. But as I told you, in RSTP, when link will goes down, it will remove that BPDU from that interface quickly. Wait, I am going to make you understand forward delay time also. Is it clear? First of all, tell me.
Means it will flush that MAC table within that.
Not MAC table, na BPDU.
BPDU.
It will flush the BPDU. Here, Y switches is going to flush MAC address table. In RSTP, switch will never flush MAC table, right? Actually, in CST, remember, Y switches was flushing MAC address table because root bridge switch was sending TC bit on BPDU, and whenever switch was receiving TC bit on BPDU, switch was setting their MAC aging time to 15 seconds, right? But here switch will never receive TC bit on BPDU, so switches is not going to change their MAC aging time.
So that aging time 300 is for MAC table and this is for BPDU. Am I right?
Yes, correct.
Okay.
Fine. And guys, so spanning tree. Okay. This is by default priority over here. This switch is root, sending hello after every 2 seconds. Max age time is 20 seconds, means neighbor switch who will receive this BPDU will keep this BPDU in their STP database for 20 seconds. And forward delay time is nothing but time taken by a port to move in learning state from listening state, or the time taken by a port to move in learning state from discarding state, right? Time taken by a switch to move in learning state from listening state or from discarding state to learning state. Then this is information of bridge, means designated bridge ID. Local switch information, this is information of root bridge. This switch is root bridge, that's why we are able to see same information here, right? MAC aging time is what? 300 seconds. Okay, these are cost. So we have multiple instances for each VLAN because we are not running RSTP protocol. We are running which protocol? RPVST protocol, right? So we have some VLAN here. So VLAN brief. So we have some VLAN over here. That's why it is running one instances for each VLAN. So here I can achieve load balancing as well. Okay, but again, if I will remove VLAN, say no VLAN 2 to 10. Now show spanning tree. Now you can see we have only single instances. So this is exactly like RSTP protocol. If we have only one VLAN on switch, then there is no any difference between RSTP and RPVST. Right? On switch number 2 also, here we can say no VLAN 2 to 10 and now show a spanning tree. Fine. If you want to see practical of topology change in RSTP, so what I can do, I can turn off these devices and I can open tomorrow topology. Yesterday topology. Yesterday we were discussing in this topology, I think this was topology, right? In this topology, if I will configure RSTP on all switches, and then if any link will goes down, you will see topology will converge quickly. So let me access switch 1. On switch number 1, on all switches I have to change a spanning tree mode. Config T, spanning tree mode rapid PVST. Done. Do so spanning tree summary. Fine. On switch number 2 also, let me change spanning tree mode. Spanning tree mode rapid PVST. On switch number 3 also, I am going to change mode. Spanning tree mode rapid PVST. Now again I am going to send 10,000 packet from PC1 to PC2. And on LAN interfaces, you need to enable what? Port fast. So let me take you to switch 2. First of all, let me configure link between switches as trunk. So here interface range is 0/0 is 0/0 and E 0/1. Switch port trunk encapsulation .1q and switch port mode dynamic desirable. Right. Then on switch number 2, interface E 0/1 switch port trunk encapsulation .1q and switch port mode dynamic desirable. Fine. Now here I am going to run a spanning tree port fast edge default. Fine. On switch number 3 also, let me enable port fast feature. Switch spanning tree port fast is default, right? And on switch number 1 also you should enable it. By the way, we don't have any access port on switch number 1, but also let's say we will connect some computers with switch number 1 also in future. So here also I am going to enable port fast feature, right? And now let me send some packet to PC number 2. Ping 20.1.1.1. First of all, let me check I'm able to ping or not. I'm not able to ping. So IP interface brief 10.2 correct on PC1. So IP interface brief 10.1. Okay, on switch number 2. So MAC address table. It is learning MAC address 10/2 correct. It is learning MAC address of PC2 as well. So ping should work. Then wiping is not working. So a spanning tree oh, so still we have some VLAN over here, right? Say no VLAN. Let me check VLAN first. Do so VLAN brief. See guys, here we have lots of VLAN. So in this scenario, if you are running RPVST or PVST, right, CPU utilization of switches is going to be very high because it is going to maintain one instances for each VLAN. So if you will check a spanning tree database, you will find 600 or 700 number of instances. So here say no VLAN 224096. Oh, command is rejected. Let's say 1000. Right? Do so VLAN brief. No VLAN 1001. Fine. And E0/2 E0/2 is in default VLAN, right? Now I think let me check switch 3 configuration also. Do so VLAN brief. 0/2 and 0/3 is in VLAN 1. Okay, again I am going to ping from PC1. Oh, so VLAN brief 0/2 and 0/3, these two interfaces are in VLAN 1. So interface trunk 0/0 and 0/1 is my trunk link, and so MAC address table, it is learning MAC address of PC1. Let me check MAC address of PC1 as well. So interface F0/0 include BIA in last it 894 times 0, 894 times 0. So this switch is learning MAC address of PC1 on this interface, correct, on switch 1. So MAC address table 89, this switch is also learning MAC address of PC1 on 0/0, correct, and MAC address of PC2. So run, so interface F0/0 include BIA F94 times 0. So MAC address table, this switch is learning MAC address of PC1 on 0/0, correct, and PC2 MAC address on 0/2, correct, fine. On switch number 1, so MAC address table, switch 1 is not learning MAC address of PC2, right? So here, so interface trunk, so E0/1 is configured as trunk and all VLANs are allowed over here. Okay, on switch number 3, so interface trunk 0/0 and 0/1 is configured as trunk. Okay, so ping should work then. Why ping is not working, man? Ping, oh sorry, I am pinging wrong IP address, na? IP address of PC2 is 10.2. Ping 10.1.1.2. See, ping is working. Let me repeat some packet. Right, now I am going to down link between switch 1 and switch 3. Switch 1 and switch 1 and switch 3. Which link? 0/0. So this is direct topology change. Interface E0/0 say shutdown. See, only one packet has dropped here, right? That means within 2 seconds, right? RSTP have reconverged the path, means change the path. Earlier PC1 and PC2 was communicating through this path. Now it is communicating through this path.
How to trace that one? In the routers, we use trace route, right? Here, do we? How do we trace the path?
You have to check MAC address table of switches. You have to find this MAC address switch 2 have run on which interface, switch 1 have run which this MAC address of PC1 on which interface. Like that you have to trace. Like if you will see now, switch 2, earlier switch 2 was learning MAC address of PC2 on this interface, but if you will check MAC address table of switch 2 now, you will see it is learning MAC address of PC2 on this interface, right?
Okay.
0/1.
Switch switch 3 we need to check now.
Switch 3 also we can check. Switch 2 is learning MAC address of PC2 on 0/1 interface. 0/1 interface. See, ping is still working. Again, if link between switch 1 and switch 3 will come up, say no set here, right? See, my ping is still working. And now if you will again check MAC address table of switch 2, now you can see this switch 2 have learned MAC address of 0/0 interface, right? That means now we are using which path? This path. Earlier we were using this path. So this is all about STP, spanning tree protocol. Clear? So how RSTP protocol is fast? Because of flags. RSTP is going to use proposal and agreement flag for fast convergence. In direct topology change also, you can see again PC1 is able to ping PC2. If I will don link between switch 1 and switch 2, this is what? Indirect topology change. This is indirect topology change. So let me take you to switch 2, and on switch 2, 0/0 interface is 0/0 says shutdown. Again you can see topology has converged. Only one packet is dropped here. But in the CST or PBST or PBST plus, it was taking lots of time when to change was occurring, right? Like in direct topology change, it need 30 seconds. In direct topology change, it need 50 seconds. So in RSTP only you need to run one feature, that is port fast, right? And protection are exactly same like CST in RSTP also. To protect root bridge, you will configure root guard, right?
What about MST? Will you take MST?
No, MST.
Multiple
Oh,
span.
MST, you can watch one video. You know, MST video is available on my channel if you want to learn. MST is, to understand MST, you have to understand VTP version 3. In VTP, we have 3 versions, right? Version 2, version 3, version 1. So generally, we are using VTP version 1 and 2, right? But in MST, we are going to use VTP version 3. In BTP, let's say, see, in this scenario, if we have single VLAN, then only one switch is going to become root bridge. Let's say we have multiple VLAN on these switches. So for all VLAN, RPVST protocol is going to run a single instances, right? That means we can configure multiple root bridge, right guys? But in MST, you can configure the scenario so that, let's say, switch 1 should maintain one instances, let's say for VLAN 1 to 10. For VLAN 1 to 10, what I want, switch 1 should maintain one instances. Because in PVST or PVST plus or RST, RPVST, we don't have capability to configure a switch so that switch should maintain single instances for multiple VLAN, right? But in MST, what we can achieve, we can tell to switch so that you should use only one instance for VLAN 1 to 10, and for VLAN 20 to 30 you should use another instance, right? Now what we can do, For VLAN 1 to 10, switch will have only one instance. So we have reduced what? CPU utilization as well. Because in RPVST, if we have VLAN 1 to 10, that means this switch is running 10 number of instances. This switch is running 10 number of instances. So CPU utilization of switch is going to be high. But in case of MST, so we come up with MST just only for one reason, to reduce CPU utilization. So here we can manually create instances. In RSTP or in RPVST or in CST or in PVST plus, we are not able to create instances manually, right? But in MST you can create instances manually. You can watch video on YouTube on my channel about MST. Now our next topic is ether channel. So can anyone tell me, in this scenario, what is problem now? Is there any problem now? Or let's say, let me design one topology here. Switch 1, switch 2. I have one link over here and I have one server here. Server, this is my server, right? My outside user are accessing this server every day, right? Let's say this switch is connected with one router and this router is connected with internet, and through internet I have multiple branch, right? So my outside user are accessing this server, many time in day. So because we have less bandwidth between switch 1 and switch 2, sometimes users are facing slowness. Or on this link, sometimes we are observing congestion. We are observing congestion over here. So what I need to do? I need to increase bandwidth between switch 1 and switch 2, yes or no? So how you will increase bandwidth? You will connect one more link here, but what STP will do? STP will block this link. You will connect one more link here, again STP will block this link. If you will connect one more link over here, again STP will block this link. STP will allow only one link to be in forwarding state between switch 1 and switch 2, yes or no?
Yes, yes, yes.
So to avoid this problem, right, to increase bandwidth between switches by connecting multiple link, we come up with technology called ether channel. Now through ether channel, what I will do, I will bundle these interface, right? Ether channel is nothing but a technology which is used to bundle multiple physical link into single logical link, so let's say I have bundled these all interfaces together through ether channel. So a spanning tree protocol is going to work on port channel, on logical port, not on physical port, right? So let's say we have one port channel over here, P1, here P1, right? This is virtual port, virtual link, right? By combining these all physical link. So a spanning tree protocol will work on this link. Now a spanning tree protocol will not work on physical link. Now again, question is what? If we are using again multiple link, right? Because when the user will send data, definitely switch will forward the data from physical link. So again, there is chance of loop, that when switch 1 will forward broadcast message, switch 2 will receive that broadcast message on this interface, so it will forward from this interface. So this is what you need to learn in ether channel, that how loop will also not form, and we can utilize multiple link between switches as well. Again, in ether channel we have two methods, static and dynamic. To configure ether channel we have two methods, static and dynamic. In dynamic we have two protocol, one is PAGP and one is LACP. PAGP is Cisco proprietary, LACP is open standard. I'm connecting only two links now. Switch 1, switch 2. By default, STP will allow only one link, but Through ether channel, if you will combine these two link, let's say through ether channel I have bundle these two link. This is 0/1, 0/2, 0/1, and 0/2, right? So see, for bundling multiple physical link into single logical link, there is some requirement. There's some requirement like trunk should be same. Like one, if you are bundling these two link, right? So both links should be what? Trunk, or both links should be what? Axis. A speed of both links should be same. Trunk encapsulation protocol should be same. Duplex should be same. Then only ether channel will work, right? Let's say this interface is trunk link and this interface is access link, right? Then ether channel will not work. Ether channel will not come up. Or here we are running in trunking encapsulation protocol ISL, or here we are running trunking encapsulation protocol .1Q. Then again ether channel will not work. Let's say here speed is 100 Mbps, here speed is 10 Mbps. Again ether channel will not work, right? Let's say duplex over here is half and duplex over here is full. Then again ether channel will not work. So requirement is these all parameters should be matched. Or let's say upper link is fast Ethernet link. Ethernet type should be also same. And this is Ethernet link, right? Again, even you have configured same speed, then also ether channel will not work. So if you are combining 2 ports or 4 ports or 8 ports, doesn't matter, you should check these all parameters. These all parameters should be same. Then you can bundle it. Let's say all parameters are same. So here I can bundle these both interface into single logical port. That is, let's say my port channel 1. Here also on switch number 2 also I have bundled it to port channel 1, right? Now a spanning tree protocol will work on this port channel. STP will work on this port channel, right? So now both port is in forwarding state, right? This port will become what? DP. This port will become what? RP, correct? Now let's say here we have one user. PC 1, PC 2. IP address of PC 1 is 10.1.1.1. IP address of PC 2 is, let's say, 10.1.1.2. Right? Now 10.1 want to communicate with 10.2. 10.1 need MAC address of 10.2, so it will generate one ARP request message, and as you know, ARP is broadcast. Source MAC will be MAC address of PC1 and destination MAC will be OLAF broadcast. Right? When switch will receive this frame, right, switch will forward this broadcast message from one of its physical interface. Maybe it will forward from this interface or from this interface. It totally depends on load balancing algorithm, what load balancing algorithm we are running, right? So in ether channel we have to understand load balancing as well. So let's say switch 1 have sent this broadcast message to switch number 2 from 0/1, right? When switch 2 will receive this broadcast message on this port, it will check what? Destination MAC. Destination MAC is what? Broadcast. But switch 2 will forward this broadcast message from their all interfaces except those interfaces which are member of same port channel group, right? So 0/1 and 0/2 both are member of same port channel group. So switch 1 is not going to send broadcast message from 0/2 interface. What I am saying? When switch 2 will receive broadcast message on 0/1 interface, it will forward that broadcast message from their all interface except those interface which are member of same port channel group. So this is how loop will not form in ether channel. Still switches are using 2 link, but loop will not form here. Got it? Got it, guys? One second. I think ether channel is last topic, right? Then we have no. Port security is there. Port security and switching.
HSRP,
Yes, HSRP,
we have
HSRP, VRRP, GLBP.
PLB.
Okay. Yes.
And we have this VSS and VPC.
No. There is part of data center.
Okay, that is advanced technology of this ether channel, right?
Even we cannot perform, lab of those VPC here in EVNG or in GNS3
No, just you can tell that overview.
process.
Overview. That's it.
Yeah. Okay. I will tell you.
Okay. Thank you. Thank you.
That is, also kind of ether channel, right? Because see, you can bundle these two link here between switch 1 and switch 2. But in data center, if I will tell you the design of data center, let me tell you. Let's say I have this design. Distribution layer switch, distribution layer switch, access layer switch, or let's say we have only single access layer switch here, right? Distribution layer switch 1, distribution layer switch 2, access layer switch 1. Here we have users. Now, again, distribution layer switches are connected with upper devices. Like here we have routers. This is my design. In this scenario here, STP will work. Here spanning tree protocol is working, right? So STP will do what? Let's say core switch 1 is my root bridge. So this port is DP, this port is DP, this port is RP, this port is DP, this port is RP, and this port is
Alternate.
alternate, right? Even now we have less bandwidth between distribution layer and access layer. So if I will connect even more cable here, right, spanning tree protocol will block that. Spanning tree protocol will block that. So in this scenario, sometime in data center, you know what you need to do. You need to configure ether channel over here. You need to bundle these two interfaces together so that STP should not block this link. Because generally in data center, we want to utilize both link between distribution layer and access layer. So can I bundle these two interfaces? No, I can bundle these two interfaces together if both interfaces are connected with same switch. But here you can see this port is connected with different switch, this port is connected with different switch, right? So in data center, what we are doing, actually we are combining these two switches into single switch first. We will combine these two switch into single logical switch, and then you can see both port of access layer switch are connected with single switch. Now we can configure ether channel. So this is what? This is VPC, virtual port channel.
How we can make this distribution two switches, sir, make it that single?
You can configure stacking. With the help of stacking also you can combine physical switches into single logical switch.
Will it work on all switches?
No, it will work on Cisco Nexus switches only, right? So
In
our
other
concern is
switches, how
not
do
learning.
in other
Yes,
switches, how do we do this one? This.
This is VPC, right? Actually what you said. This is what
yes, VPC.
virtual
What?
port channel.
Correct.
What about with that VSS? How it will work?
VSS will also work like same. Both are same.
Then what is the difference that VSS and VPC?
Configuring and technology both are different technology. Logic is same. Logic is simple, combining multiple physical switches into single logical switch, and then configuring ether channel,
Okay.
right? So actually we have video also on this topic on my channel.
Means first we can make the that multiple switches on that single
Into
logic.
single logic, yes,
Yeah.
and
Okay.
then we can combine
Okay.
multiple physical port into single logical link to avoid STP blocking port, so that STP should not block any port, right? But our concern is not learning this technology. Our concern is learning ether channel in this technology, right? In this type of scenario, how ether channel is going to work. Do you know stacking?
Can you please explain briefly for that stacking?
In stacking, see, let's say I have one switch here, I have one switch here, right? Now here we have some users. Again, here we have some users. Let's say this switch is 48 ports switch. 48 ports are there, and here also we have 48 ports, right? Now we need to connect switch 1 and switch 2 together. So how you will connect? Through Ethernet cable. Through Ethernet cable, what speed you will get? 100 Mbps.
Yes, yes.
100 Mbps. Now let's say on switch number 1 we have 40 users. 40 users, or let's say, okay, let's say 40 user, right? Now one user will get how much bandwidth between switch 1 and switch 2? If all 40 users are communicating with, let's say, internet, or switch 2 is connected with any other routers, so one user will get very less bandwidth, right? So in the same way, let's say on this switch we have more than 100 ports and more than 100 devices are there, right? So one user will get around 1 Mbps bandwidth between switch 1 and switch 2. Now if I want to increase bandwidth, what I will do, I will connect one more Ethernet cable. Again I will get 100 Mbps. Again, even you will have 2 giga interface also on switches to connect switch together. To connect switches we will have gig interface as well, right? But again, bandwidth is very less. So when we need to connect multiple computers, let's say 100 number of or 1000 number of computers together, 1000 number of computers together, you need lots of switches, you need multiple switches, right? And you need good amount of bandwidth between switches, right? So this is not solution, right, to connect 1000 number of computer to switches. Here let's say you have four switches, 1, 2, 3 and 4. On all the switches there are lots of user. Here also, here also, here also, and here also, right? Now between switches I need to connect cable, right? So again, if I have 2 gig interface and we have lots of fast Ethernet link, right? So even I will use gig interface or fast Ethernet link, so we will get less bandwidth, 100 Mbps or 1000 Mbps. So we have option to combine these switches together through different type of cable, that is called stacking cable. That is called stack cable. Stack cable. If I will talk about bandwidth of stack cable, so bandwidth of stack cable is going to be more than 30 Gbps, more than 30 Gbps. And on some switches you will get a stack port, stack port, stack port, stack port. And here we have one more problem. If I will connect these all switches together through Ethernet cable, through fast Ethernet cable, or through gig Ethernet cable, right? What will happen? All switches are in single broadcast domain. Yes or no? And on all switches, you have to configure what? VLANs. Means you have to manage all switches separately. If you want to change the configuration on switch number 1, you have to access switch number 1. If you want to change configuration on switch number 2, you have to access switch number 2. But if you will combine these switches, these all switches, right? These all switch will work as a single logical switch. These all switches are going to, I'm going to connect these switches like this. Right? Now these all switches are combined. These all switches are single switch, right? Let's say this was my fast Ethernet 0/0 link, 0/1 link, right? So now this port will become maybe 1/0/1 on my rack, right? When I had access my rack, you seen interface was like this, not like 0/1 or 0/2, 1/0/1. So this 1 is representing a stack number, right? Now in these 4 switches, one switch will become main switch, right? And if you want to create VLAN, you need to create on that switch. Automatically VLAN will be created on all switch. Actually VLAN will be not there on all switches. VLAN will be there only on one switch, right? According to that, all PCs will communicate with each other. Actually these switches are now single switch. These switches are now single switch. Let's say on switch number 1 we had 100 ports. 100 ports. On switch number 2 also we had 100 ports. On switch number 3 also we had 100 ports. On here also we had 100 ports. So now we have only single switch with 400 ports. So now we can connect 400 computer through a single switch.
Do we need to
Okay.
configure trunk between the switches?
No. All VLAN are allowed on stack port.
Oh, stack. How do we configure stack port?
See, this is a stack cable, right? So you need to connect switches through this stack cable. And if you want to see configuration, configuration is not possible here in packet tracer or in simulation software, I think. So if you want to see the configuration part, just I can tell you command only. What is the command, right? I cannot show you practically. Stacking PM networking. So here you will get commands. Here is VPC configuration.
I took more than 300 interviews when I worked for Facebook. 80% of people I interviewed for problem solving failed the interview.
Hello everyone, right? So we have 3 Nexus switch here in UNG. So you can see the configuration over here, and I think a stacking video is also there on my channel. Switch stacking. Let me check stacking. What is VSS? Here is video of VSS. Let me share this also.
Hello everyone.
Do they use stacking in the production now?
Yes, yes, we are using. Okay, I will find a stacking video and I will share with you guys. Stacking video is also there on my channel. I
Yeah,
have
that
made one video.
VP,
Yes, yes.
VPC also you can share that above.
Yeah, I have shared. Na? This one is VPC.
Okay, okay.
This one is VSS. Here is VPC.
Prabhul, stacking cable
Hello
versus
everyone.
SFP. Which one is the best one?
Stacking and
SFP cable.
I don't know about SAP cable, brother.
Search on Google SFP cable.
Wait. Just 1 minute, guys. Okay, I will find this video, stacking video. If I will not find a video on stacking, then in next class definitely I will discuss stacking in detail, right? I will tell you all the concept behind it. I will also share commands, right? Yes, SFP.
Yes.
SFP.
FP.
This cable.
Yes.
This is for
It's a fiber
optical cable, right?
No, it is talking about SFP. SFP is what connector. It is telling about SFP, like
It's not only for fiber. We can use it for copper also.
like on Ethernet port. On Ethernet port, you can connect what RJ45 connector only. So if you need to connect optical fiber over here, so what you need? You need a connector. That connector is known as SFP. So SFP is just a connector, right? That will convert my port from, so that I can connect optical fiber cable also there. Otherwise, on RJ45 connect on Ethernet port, you can connect only RJ45 connector. So it is telling about that it is not cable. It is just SFP connector. It is connector. Okay. So now we will learn Ether channel tomorrow. First we will see manual configuration of Ether channel, then we will see protocols. Okay, after that we will see load balancing, how we are going to achieve load balancing. Again, to perform lab of load balancing is not possible in simulation software, so I have to prepare my rack. Okay.
Okay, sure.
Now switching, we have Ether channel, then
HSRP,
HSRP,
VRRP,
VRRP,
GLVP.
LBP.
anything else? Port security,
Yes.
anything else? SPAN,
Standard extended access list.
switch port, no, protection, so we have these topics, right, that we need to discuss.
Praful, kindly share the today video also. Okay.